Example 15 is a little bit more difficult than the previous ones. I don't know if you would see anything this difficult on the AP exam, but still something to take a look at. What makes this one difficult is if we look at our k term, we see 6 over n, so we think that delta x must be 6 over n, but in fact delta x is 3 over n. All right, so we can start by saying that delta x, which is b minus a over n, is actually 3 over n. So we know that b minus a is equal to 3. And just like we did back with the other odd examples, we need to figure out what a is equal to. All right. Now a is equal to the number that's added to the k term, but we have a little change here because again the numerators don't match up. All right. So what's really happening here? We're going to take a little sidebar. We need a 3 over n here. We have a 6 over n, so we need to divide that 2 out. Okay. So we need to think of this as the sine of 2 times 3k over n plus 2. And then we can factor that 2 out. And when we factor the 2 out, all right, we have 3k over n plus 1. Okay, now this 2 is going to come into play later on when we write our f of x. But it's actually not part of the k term. Okay, just like the sine is not part of the k term. The k term is 3k over n plus 1. Now we have the 3 in the numerator, which matches with the 3 here in delta x. And so we can clearly see that a plus k delta x is equal to 1 plus 3k over n. All right, which means that a is equal to 1. All right, so if a is equal to 1 and b minus a is equal to 3, well, b must be equal to 4. All right, so we're going to have the integral from 1 to 4. All right. Now, in addition to that, we now have to write our integrand. In the integrand, we see the sine in the 2. Now, the 2 was not originally here, but it is here. So here's our k term. That's going to become our x, but we have the 2 there. All right, so we have the sine of 2x. Okay, and the delta x becomes our dx.